In this video, we're going to be looking at the properties of rational exponents and radicals. Our learning objectives are: use the properties of rational exponents to simplify expressions with rational exponents, and use the properties of radicals to simplify and write the radical expressions in its simplest form. Simplify the following expressions. 5 raised to 2 over 3 times 5 raised to 4 over 3 is, we're going to add the exponents. 2 over 3 plus 4 over 3. So that's going to give you 5, 6 over 3. And 6 over 3 is the same as 5 square, and 5 square is 25. The next one is going to be the same idea like the first one, raised to 1 over 5 plus 4 over 5, and that's going to be actually giving you 3 raised to 1. 5 divided by 5 is 1, or simply 3. Next, this is raised to a power. What I can do in here is actually to cancel that 3 together, and I'm going to be left with 4 square, which is 16. This is going to be a subtraction. 8 of 5 over 2 minus 1 over 2 is going to give you 8 4 over 2, and 4 divided by 2 is 2. So that's going to give you 8 squared, which is 64. Okay, next is going to be the last part, number 5 in here. So this is going to be the same thing. It's subtraction. So it's going to be 7, 2 over 3 minus 5 over 3. So it's going to produce a negative exponent. That's going to give you negative 3 over 3. And negative 3 over 3 is the same as negative 1. So that's going to give you 1 all over 7. Okay, that's all for the warm-up. Okay, so let's look at the different properties of rational exponents. So the first one is the product of powers. So you're given a number a raised to m multiplied by a raised to n. That's going to give you a m plus n. We're going to add their exponents. The power of a power, say a raised to m, and it's raised again to another power n, we're going to multiply its powers, m and n. The power of a product is characterized by two different numbers raised to exponent m, and what we're going to do with this is just to simply distribute the exponent a raised to m and then b raised to m. The negative exponent, so let's say a number a is raised to a negative exponent, we can simplify it by creating a fraction and making the exponent positive. But in here, the condition is that a should not be equal to 0, or the denominator should not be equal to 0. Here, 0 exponent. Okay, a 0 exponent means that's going to be equal to 1, but always remember that the value of a should not be equal to 0, because 0 raised to 0 is still undefined. Okay, next is the quotient of powers. So the quotient of powers is two numbers raised to m, and they are going to be divided by a raised to n. We just subtract their powers, m minus n. Now, remember again that in here, the value of a, the denominator, should not be equal to 0. The power of a quotient. So in here, what we're going to be saying is, let's say, a fractional a and b raised to m. That's going to give you a raised to m all over b raised to m. Now, provision again, b should not be equal to 0. So these are the different properties that we're going to be looking at in this video. Use the different properties of exponent to simplify each expression. Okay, so let's simplify this one. This is going to give you 7 raised to 1 over 4 plus 1 over 1 half. That's going to give you 7 and 3 over 4. Okay, the second one, 6 raised to 1 half times 4 raised to 1/3 the quantity square. Now, if you're going to take note in here, the bases are different. So what we can do is just to distribute these things like that. So that's going to give you 6 raised to 1 half and then raised to 2 again, multiplied by 4 raised to 1 over 3, then raised to 2. Now, 2 divided by 2 is just simply 6 raised to 1, and then we're going to multiply that by 2. That's going to be 4, 2 over 3. So, in essence, the final answer is just going to be 6 times 4 and 2 over 3. Okay, so next, if we are going to take note in here, we can see that their exponents are the same. So we can actually put these two together. Okay, so maybe the best way to do it is to, let's say, 4 times 3 raised to 5. Okay, and then we're going to raise it again to negative 1 over 5. So that's going to give you 12 raised to 5. And then we're going to raise it again to negative 1 over 5. So that's going to actually give you to, let's say, 12. 5 times negative 1 over 5 is the same as negative 1. To simplify it further, that's going to give you 1 all over 12. Okay, that's the answer. Okay, let's look at the next one. That's going to be 5 divided by 5 raised to 1 over 3. Now, the exponent in here is automatically 1. So let's do that. 5 raised to 1 minus 1 over 3. And that's going to give you 5 raised to 2 over 3. That's the simplified form. Okay, so let's see the properties of radicals. Let a and b be real numbers and let n be an integer greater than 1. Now, the product property simply says that the nth root of a times b is the same as the nth root of a times the nth root of b. Okay, so let's give you an example. Let's say the cube root of 4 multiplied the cube root of 2 is the same as the cube root of 8, and the cube root of 8 is 2. Okay, next, we're going to look at the quotient property. Quotient, it's going to signify that you're going to divide. So let's say the nth root of fraction a over b is going to be the same as the nth root of a over the nth root of b. Now, the provision in here is that b, or the denominator, should not be equal to 0. Okay, let's give you an example. The example, let's say the fourth root of 162, and we're going to divide that by the fourth root of 2. So here we can actually put these together since they have the same index. So we can say that 162 over 2. Now, what is 162 over 2? That's going to give you the fourth root of 81, and the fourth root of 81 is simply 3. Okay, so these are the properties of radicals that you're going to be using over this lesson. Okay, simplify each expression. The cube root of 12 multiplied by the cube root of 18, so we can put that together in one radical sign. That's going to give you 12 times 18, and 12 times 18 is going to give you 216. Now, the cube root of 216 is simply 6. Okay, number 2, so we're going to put them together. So that's going to give you the fourth root of 80 divided by 5. And 80 divided by 5 is going to give you 16. So that's going to give you the fourth root of 16, which is simply 2. Okay, so in here, we're going to simplify this expression by writing its simplest form. So number 3, the cube root of 135. Now we know that 135 is the same as 27 times 5. Yeah, 27 times 5 is also the same as 135. So let's see. The cube root of 27 times 5. I chose 27 because 27 can be written as 3 cube. Okay, 3 cube is the same as 27. So that's going to be 3, the cube root of 27 times the cube root of 5. So this is 27 is a perfect cube, so that's going to just give me 3, the cube root of 5. So this is your final answer. Okay, number 4, the fifth root of 7 divided by the fifth root of 8. Now, in here, this is very nice because you need to create a perfect fifth on the denominator. Okay, so let's rewrite it. The fifth root of 7 and the fifth root of 8. Now, in order for me to create a perfect fifth, I can say that 8 times 4, which is 32, is the same as a perfect fifth of 2 raised to 5. So 2 raised to 5 is the same as 32. So I can say that if I'm going to multiply the fifth root of 4 in here, and I'll do the same thing on the numerator. Okay, so this is going now to give me a perfect fifth on the denominator. So on the numerator, this is going to give you the fifth root of 7 times 4 all over the fifth root of 8 times 4. And that is going to give you the fifth root of 28 all over the fifth root of 32. Now, we know that the fifth root of 32 is 2. So we're just going to leave our answers as the fifth root of 28 all over 2. At least the most important thing is we were able to rationalize the denominator. Writing radical expression in its simplest form. Now, I would like you to take note of this, that when you say radical expressions in its simplest form, it means that there are no radicals, say no radicals in the denominator. Okay, that is the definition of simplest form. Now, one keyword that I would like you to remember here is the word conjugate. Okay, the conjugate is actually just the opposite. Let's say in this case you have 5 plus root 3. The conjugate of that is going to be 5 minus root 3. So we're going to use the conjugate of 5 plus root 3 to solve this specific problem in its simplest form. Okay, let's rewrite the expression. 1 over 5 plus root 3. Then we multiply by the conjugate, which is 5 minus root 3 divided by 5 minus root 3. Continue the process. We're just going to multiply both sides. This is going to give you 1 multiplied by 5 root 3. Then in here, if you're going to notice the denominator side, this is actually the special binomials a plus b and a minus b, and the product of that will just give you a squared minus b squared. So they are on the same form. So what I'm going to do with this is just going to say 5 square minus root 3 square. Okay, so let's continue down. So if I'm going to do this one, it's going to give you 5 minus root 3. Okay, multiplying 1 times 5 root 3. Now here we go. I'm going to simplify this one. It's going to give you 25, And if I'm going to cancel this one together, what is there is just going to be 3. So that's going to give you minus 3. Therefore, my final answer here is going to be 5 minus root 3 all over 25 minus 3 is going to give you 22. So this is now your final answer in here. Okay, so please don't forget the word conjugate. Conjugate is what you're going to be needing when you're going to see these types of expressions. Okay, here's another one. Let's simplify this number 2. Okay, 3 over 6 root 2. So if we're going to get the conjugate of the denominator is going to give you 6 plus this time, okay, and then 6 plus root 2. Okay, so let's continue the process. That's going to give you 3 times 6 plus root 2. And then this is going to give you 6 squared minus root 2 square. Continue here. That's going to give you your 18 plus 3 root 2. And then 36 minus 2. Okay, continuing here, it's going to give you 18 plus 3 root 2 all over 36 minus 2 is 34. Now we can break this one. 18 over 34 plus 3 root 2 all over 34. Now we're going to cancel this out, divide it by 2. So that's going to give you uh, 9. That's gonna 18 divided by 2 is 9. 34 divided by 2 is going to give you 17 plus 3 root 2 over 34. Okay, so far that's going to be its lowest term. Okay, so there's one more here, number 3. 1 over 2 plus root 5. So let's get the conjugate. The conjugate will be 2 minus this time root 5 all over 2 minus root 5. Okay, let's continue the computation. That's going to be multiplication. 1 times 2 minus root 5. This is going to be 2 square minus root 5 square. Continuing here, 2 minus root 5. This is going to be 4 minus 5 here. Continuing here, that's going to give you 2 minus root 5. 4 minus 5 is negative 1. So if you're going to break it out something like this, 2 over negative 1 minus root 5 over negative 1. So in here, you're going to have negative 2 only. And then plus, this is going to be plus root 5. Okay? So that's your final answer. Now, radicals can also be added. So just like for this example, fourth root of 10 plus 7 times fourth root of 10. So the good thing in here is that we're just going to put all the like terms, okay? So to answer this one, this is just going to be, and there is also an invisible one in front in here. So that's going to give you 1 plus 7, okay? And then the like terms is going to be fourth root of 10. To simplify it, that's going to give you 8 fourth root of 10. Okay, simple as that. Okay, so here's another one. So if you're going to be looking at this one, 8 raised to 1 over 5 is actually a common term in here. So these two are actually very common. They are like terms, okay? They are like. But if you would like to look at it in its radical form, the radical form of that is going to be 2 times the fifth root of 8, okay? Plus 10, the fifth root of 8. Okay, so we're going to put the like terms together. So 2 plus 10, that's going to be 2 plus 10. And then you're going to have the fifth root of 8. So the final answer is going to give you 12 and the fifth root of 8. Okay, so here's the last one. In adding and subtracting like radicals and roots, in this case, we're going to subtract. So the common things in here, as we know, is the indices. They are both the same. But the thing that we have to do here is to simplify 54 first. Okay, since we're dealing with cube roots, we can say that 54 is also the same as 27 times 2. Now, 27 is a perfect cube, okay, minus cube root of 2. So the cube root of 27 is going to be 3, then the cube root of 2 minus the cube root of 2. Now, there is an invisible 1 in here, okay? So to finally answer this one, your final answer now in here is going to be 3 minus 1 is going to be 2, the cube root of 2. That's your final answer. This is all for now for the properties of rational exponents and radicals. If you find this video very helpful, share and subscribe. Thank you very much.